All right, people. So today we're looking at B3.3, and that's movement. In this component of B3.3, we're going to look at how joints help our bodies to move. So this is page 298 to page 303, and we are looking at form and function. So when we're thinking about skeletons protect and support our body. They allow movement by allowing attachment points for muscles and acting as levers. So an insertion point causes muscle contraction. And so that's where the tendon would attach to the bone. And then the origin point is fixed, and it's going to be where the muscle is attached to the bone. And so there's going to be a tendon here as well that attaches the muscle to the bone. But the origin is where the movement is not happening from. The insertion is where the movement happens from. And so your bones act as levers, and they can change the size and direction of force. So levers that are far from the fulcrum have a lot of force, but little movement, while the vice versa is also true. If they are close to the fulcrum, they have more movement, but they have less force. So muscles are antagonistic to facilitate movement, and we have three different classes of levers. You don't need to memorize the types of levers, but you can see here the first class lever is with a fulcrum in the middle. That's the screen triangle. And then this muscle here is going to move your head back and forth. So we have a medium amount of movement happening in our neck. A second class lever, the fulcrum is down here at your toes and your heel is rising up. And so there's not a lot of movement as your heel rises up, but there is a lot of strength. You can lift your whole body that way. And then a third class lever is quite close to the actual muscle action here. And as a result, you have a big range of motion, but you don't have as much force as you would with, for example, your foot here. And then when we're looking at our joints, the structure of the joint determines the range of motion possible. We have ball and socket joints. Those are our hips and our shoulders. And so we have a full range of motion happening with our shoulder joint. I'd obviously show you my hip rotating around, but you can do that with your own hip. And then hinge joints, elbows are hinge joints, so they rotate forward and backwards. And your knee is also a hinge joint, but it has a bit more flexibility just due to its structure. And then abduction is movement away from your center mass. So if you lift up your arm like that, you're moving away from your body. That is abduction. Whereas if you're moving your arm back down towards your body, that is adduction. Flexion is when bones move to decrease the angle of a joint. And so I would be flexing my arm. This is flexion when I reduce the angle here at my elbow. And then the opposite of that is extension, which is increasing the angle of the joint. And we can measure joint angle using a goniometer, I'm sorry. And so when we're looking at a joint here, bones are anchor points for muscles and ligaments. And ligaments are going to hold bones to bones. If you rip a ligament, it's really hard for it to repair itself. So you typically need surgery. And you've probably heard of anterior cruciate ligament surgeries in people's knees. That's a very common ligament to tear from side to side movement. And then tendons hold muscles to bones. And so you can strain a tendon. Actually, if you lift weights, your tendons are kind of your weakest point because they don't build very quickly, and they can rip or tear partially. They will repair themselves, but it takes quite a lot of time, and it's assuming it's not completely damaged. Cartilage is the tough, smooth tissue that you can find in your ear here, but it's also on the surface of your bones, and it's going to prevent friction between bones and absorb shocks. Inside the joint capsule here is synovial fluid, and it prevents friction of the cartilage. And the joint capsule is sealed and it prevents dislocation of the joint, while the muscles provide the force that causes the movement at the joint. So antagonistic muscles are muscles that work opposite one another. So your bicep and your tricep are antagonistic muscles. If you contract your tricep has to be relaxed in order for your arm to bend, and vice versa. You contract your tricep to straighten your arm. So intercostal muscles are the muscles in your ribs or between your ribs, and they're examples of antagonistic muscles. And when the external intercostal muscles contract, the internal intercostals relax, and then your ribs lift up and you can breathe in. So here would be your externals and here are your internals, and they're working opposite one another. And animals used to be on land, early mammals, but about 50 million years ago returned to the water. And so water is about 1,000 times more dense than air, which means in order for organisms to be able to find food, escape from danger, search for a mate, and migrate, which is all of the reasons why organisms move, animals in water needed to be more streamlined. So thinking about a dolphin structure, they're tapered and have a smooth surface. Their movement uses fins and tails, but their blubber, which is the fat layer underneath their skin, keeps them floating when they're sleeping. And then ventilation is happening through a blowhole. So that's not connected. Their mouth and their lungs are not connected. They're not breathing through their mouth. They're instead breathing through a hole on their head. So to summarize, bones, joints, and muscles work to move our bodies by acting as levers. Ligaments attach bone to bone, and then tendons connect muscle to bone. So here you can see a ligament and there's a tendon. Ball and socket and hinge joints have different ranges of motion, and antagonistic muscles oppose each other to cause movement in our skeletons. Cartilage and synovial fluid prevent friction inside joints between bones, and animals have different adaptations for movement. They move for mates, food, migration, and escaping danger. And then here is a goniometer that would measure joint angle. All right, that is it for this video. Thank you for watching.